Hi there, thank you for joining me again as we exploit the double angles and what they can do for us. I'm not going to complete part B, I'll leave it as an exercise for you. However, I'll post the solution down there such that you can compare. You can also go into the back house and do more of these examples because I would advise that. So look out for the back house, look for the trigonometrical topic, and in particular the double angles, and you'll find a couple of exercises there for you with the answers at the back. So that's the answer for that expression. I hope you do it. So I'll continue with number 4, exploiting compound angles and then the double angles because they are still the same thing. So I'll do part A of proving that identity. In most cases, I like the proof so much. Why do I like a proof? It's because with a proof, you already have the answer and they want you to find it. Okay? So you'll just be simply looking at where the answer is and then work toward the answer. So I'll start by, of course, getting the LCM there, which is sine B cos B. And once we do some simple algebra there, you find out that sine A cos B plus cos A sine B over sine B cos B is the same as the above expression. And so once you look critically, you'll observe also that sine A cos B cos A sine B is familiar to us, which was our first compound angle in terms of sine, which is sine A plus B. And then if you look at the downer one, it looks familiar but just lacking a 2. So once we introduce a 2 on it, because it wasn't there, we divide it by 2 such that we neutralize it. Once you cross out the 2, you'll still obtain sine B cos B. However, this 2 is going to help us obtain something interesting. So if you do not think outside the box, trigonometry will be hard for you. So if you look critically, 2 sine B cos B is the same as sine 2B. And so once we get our reciprocal this other side, we shall obtain sine A plus B times 2 over sine 2B. And once we just rearrange it, you'll observe that we have already proven and we have the answer there. So sometimes it's going to necessitate that you simply look outside the box. You think beyond what others are looking at and you'll be able to obtain the answer. You'll see this in a couple of exercises that I'll be giving and the others that you'll be doing. So I would advise that you think outside the box. So I'll continue with part B. Still the answer is there, and what I'm going to do is just simply exploit a few concepts to obtain that answer which is already there for me. I'm sorry I cannot speak clearly because the flu is still disturbing. And so whenever they talk of a proof, what I forgot to tell you is whenever they ask you to prove, always use the function on the left hand side to obtain that on the right hand side, not the other way around. Okay? So once we expand sine 2x, you get 2 sine x cos x. You're familiar with that already. That's a compound angle. And that is divided by 1. We want to obtain tan x. How do we obtain tan x? Just like I said, we think outside the box. Once we divide it by 1, remember 1 is the same as cos squared x plus sine squared x. So once you divide it by 1, it means you can replace it by cos squared x plus sine squared x. And at this step, you divide everything by the first expression, which is cos squared x, and there you'll have your solution. And so once I divide through by cos squared x, the upper one, 1 cos x goes with the cos x above, so you remain with 2 sine x over cos x, which is 2 tan x. Cos squared x divided by cos squared x is 1, and sine squared x divided by cos squared x is tan squared x. Thank you.